Okay, this will be interesting. What is the one prominent reason because of which the complexity of any code increases? The answer is branching. What is the one prominent way to create branches in your code? The answer is if conditions. So, what if we can write a code in such a way where we can get rid of most of the if conditions? Not only that, if we want to change the conditions at later point of time, we don't need to touch the code. We can do it externally. How awesome that will be. Hello everyone, welcome to my channel, and in this particular video we are going to talk about how to get rid of if conditions from your code, and the technique is called decision matrix based programming. Decision matrix is also known as decision tables, right? But I'm using the term decision matrix. Okay, so let's go ahead and see, and I am using Python as a programming language over here. But the idea is not to talk about Python, because decision matrix, the way I'm creating it in Python, can be created in pretty much all programming languages. I am using Python to explain it in the easiest possible way. You need to understand this particular concept and apply it in your own programming language. Okay, so let's go ahead and start. First, the definition. What's the decision matrix? Decision matrix is nothing but an n-dimensional table which helps us to take a decision, right? Think about any decisions we take in our day-to-day lives. Maybe even whether we should go ahead and watch a particular movie or not. There are set of conditions, right? Whether I like the actors, I like the series, or many other conditions, right? And based on those conditions, you decide whether you want to go ahead and see that particular movie or not. So decision matrix, the table called decision matrix, contains conditions as well as actions. Under what condition you will take some action. Pretty much similar to if condition, but taking all the conditions out of the code. Let me talk about this and let me show you the benefit of the same with the simplest possible example. Let's assume that I have a problem statement where I want to create a simple calculator. And here is my code to create a simple calculator. And this function, takes two input and the operation. And based on the operation, it does plus, minus, multiplication, and division. And if I want to call this function, very simple, I'm gonna just provide two numbers and the operation, I'll get the output. If I just use, plus over here, I'll get 30 over here, right? Now let's try to do the same thing using decision matrix. So to use decision matrix, you need to create a decision matrix, and here is how the decision matrix will look like. So here is the decision matrix. You can also consider decision matrix as a key value pair, where key represents the condition, value represents the action. Here, operation is the key and action is the value. So based on whatever is being passed, the corresponding action will be taken. Now, to be able to use this decision matrix in your code, you need to take this from a file or DB, wherever you choose to store it, and take it into your program. In Python, I'm using dictionary. You can use dictionary in pretty much all programming languages in one form or other, and you can even use the same to store a decision matrix. So here I have created a dictionary with key value pair, where key represents what I want to do and value represents the action. And I am rewriting the calculator function as this. Okay. Remember, the earlier function was this particular big function with lots of if conditions. And now I am writing a function where there is no if condition. Okay, I'm just taking things from the decision matrix and applying that particular operation. So here what I'm doing is that I'm taking input 1. Then what I'm trying to do is that I am taking the operation from decision matrix and applying it to input 2 and evaluating the expression. Okay. And if I just call this particular function, the end result will be same. You can see if I say add, result is 30. And if I say multiply, the result will be 200. Okay. Now, as you have seen that, I can use a very simple code, very simple function with decision matrix. But you might ask, okay, so fine, looks okay, but why I should make use of decision matrix? Well, the biggest reason is that, when you use decision matrix, you can extend or shrink the functionality without changing the code. Now, without changing the code is a big deal, because you have written some code, you have written set of test cases for that code, you have written set of test cases to check all the positive and negative scenario in that particular code. And if you use decision matrix, you don't need to change those test cases. Let's take an example. Let's assume that we want to extend the functionality of calculator by adding a modulo operator. So if I want to extend existing functionality without using decision matrix, here is how I'm gonna change my code. I'll add one more if condition, okay, in this particular function, and of course this will work. I can pass modulo operator and I can get the result. But if you are using decision matrix, you'll just have to update your decision matrix. Okay, I have added MOD over here, which means the dictionary will now contain one more key value, which is MOD and corresponding operation. And bingo, you can just use the same function without updating it or changing it. Look, this function calc decision matrix, which we have created earlier as this, right? We are not changing this particular function, which means this will work. You can get the result over here. Okay, so this is how decision matrix can help to apply conditions in your code from outside without changing the code. If you do not change the code, or if you have to change your code only in rare conditions, then the chances of your quality remain intact is very high. Now, this is all about a very simple decision matrix, but decision matrix need not to be simple. There can be multiple level of multi-dimensional decision matrix. Multi-dimensional decision matrix means the number of conditions can be multiple, number of actions can be multiple. Let me talk about some example, okay? Let me talk about this problem statement. If a customer belongs to a category A or category B, and the customer is having annual subscription, then the company will give 100 credit points. Otherwise, the company will give 25 credit points. Okay. So monthly subscription will get 25 credit points. This is just an imaginary example. Just imagine it for a moment. And here is how the decision matrix will look like. I have a customer as a condition, subscription as a condition. I called it multi-dimension because there are two conditions, customer and subscription. Action is only one. Now you can create decision matrix with multiple actions too, but I don't want to complicate it over here. I just want to communicate the concept to you. Now, what will happen over here is that I will create a key value pair like this. Now I have created a dictionary to represent this multiple dimensional aspect of conditions. So the key is customer type, and within the value I have another dictionary where key is yearly or monthly. Okay. Now let me create a function to return the credits. I'll just take input tuple, which means input customer and frequency, and I'll get the return values. So if I want to get the credits of customer A or B with yearly subscription, I'll get 100. Otherwise, I'll get monthly. Okay. Now, so far so good. The benefit you can visualize with this particular condition. Let's assume that tomorrow we have to add another set of customers called C and D with yearly subscription getting 200 credits or monthly as 50. Maybe they are premium customers. Okay. So you can just change the decision matrix, and without changing the code, you will get the desired results. And this is how you can expand your code, your program, to the extent limited by just your imagination and creativity. Okay, so as I have mentioned, the biggest reason to use this kind of idea or concept is that you don't have to write new test cases for the code which is already tested and regression tested. You may need to add a new test case for just checking the functionality of the new system, but maybe even regression is not required to the extent it is required when you change the code. Okay, and not only that, even if your system is working in a production system, you can change the decision matrix wherever you have stored it, in a file, in a table, in a database. Okay, you can change that without changing the code, without making sure that you have to redeploy the code. Okay, and this is the biggest USP of decision matrix based programming. Okay, so I do hope and believe that I have explained the concept of decision matrix based programming to all of you in the easiest possible way, and I do hope and believe that you are going to make use of that. Thank you all. Thanks for watching. See you again.